Okay, let's continue with this next example. If you'll remember, we solved polynomial inequalities a while ago with polynomial inequalities. You can either graph them and then decide where things are greater than 0, or you can do a number line and plot the zeros and go from there. With these rationals, I would encourage you to graph them. I think that's going to be the best method. So let's go ahead and try this. Here's our strategy. Step 1, we're going to graph the left of this inequality. Step 2, we will graph the right of this inequality. Step 3, we're going to find any intersections of the left and the right side. And then step 4, we're going to analyze and write the intervals that answer this inequality. So we'll start with green. We'll graph the left. I apologize, I'm yawning. It's late at night and I'm sorry. Okay, so here's my coordinate plane. All right. Graphing this function, x plus 2 over, I'm going to factor this x minus 3, x plus 3. So I have vertical asymptotes at x is 3 and negative 3. Go ahead and draw those in. The degree here is proper, so I have a horizontal asymptote at y equals 0 there along the x-axis. Then to graph this, let's find the x-intercept. So we'll let y is 0, so 0 equals x plus 2, and x is equal to negative 2. So we have a point right there at negative 2. And then our y-intercept, let x equal 0, so y is equal to 0 plus 2 over 0 minus 3 times 0 plus 3. That's 2 over negative 9, so negative 2/9 is about right there. Okay, so since we have 2 points there, we can assume that this part of the function is going to look like that. Okay, if we analyze our multiplicity, we have multiplicity of an odd degree of 1. So that means we're going to have a sign change. So if this section of the graph is going up, then to the left of that asymptote, we're going to go down. That's what a multiplicity of 1 tells us. So this comes up that direction. This asymptote over here also has a multiplicity of 1. So if this arrow is going down, then this arrow here goes up on the left. And we're in pretty good shape. Whoops, except, my notes disappeared. Let's try this again. So now we have successfully graphed the function on the left. Now let's go ahead and graph the function on the right. Negative 4/5 is just a horizontal line at negative 4/5. So that's going to be about right here. It's negative 4/5, and here is the equation of that line. Okay, next thing we need to do is find some intersections. So we have an intersection here, here, and that's it, just those two. So to find the intersections, we need to go ahead and solve the original inequality, but change your inequality sign to an equal sign and solve for x. So we'll say x plus 2 over x squared minus 9 is equal to negative 4/5. And again, this is going to tell us the actual x coordinates of these intersection points right here. Cross multiply, and we get 5x plus 10 equals negative 4x squared plus 36. Combine like terms, get everything over to one side. So I'm going to add 4x squared over here. I've already got 5x over there, and then I'm going to subtract 36, and that gives me a negative 26 equals 0. This quadratic here can be solved. It can actually be factored, but it's kind of tricky, so I would just suggest using the quadratic formula. This would be a good time to pause the video and go ahead and work out the quadratic formula and then hit play and see if you've done it correctly. If you've done it correctly, you end up with negative 5 plus or minus 21 over 8, and this gives you 2 and negative 13/4. So those are your intersecting points here. So this number, so the number 2 represents this coordinate here. So our graph isn't perfect, so this green one must have come over a little bit more so that it intersects here at 2. And then negative 13/4. Negative 13/4 is approximately negative 3 1/4. So 1, 2, 3 1/4. We're pretty close with that one there. Okay, so now the question is, if this is the x value, negative 13/4, and this is the x value of 2, we can decide where our green function is greater than the red function. So our green function is greater than the red function here, and here, and here. So go ahead and write the inequality that represents that intersection and where it's greater than the red line. So we are going to have negative infinity until, so negative infinity until we get to negative 13/4. Union, we pick up again here on our vertical asymptote at negative 3. And we stay above the red line until this point here at 2. And then we pick up again to the right of the asymptote at 3 and go to infinity. And there's your answer.